Hello friends, welcome back to my channel. Let's begin with the second part, quotient rule. So y is equal to fx upon gx. Whenever you have given a function where y and two functions are divided, then the differentiation dy by dx is equal to, first we will square the denominator, then keeping the denominator constant, we will differentiate the numerator, then apply minus sign, then keep the numerator constant and then differentiate the denominator. So it will become dy by dx is equal to gx into f dash x minus fx into g dash x whole upon gx the whole square. Let's understand by the example. Y is equal to 2 power x upon x square. Differentiation dy by dx is equal to, first we will square the denominator, so x square the whole square, which will become x power 4, and then we will keep the denominator constant x square and differentiate the numerator, which is 2x ln 2, then apply minus sign and keep the numerator constant 2 power x and then differentiate the denominator, that is 2x. So we will get x square into 2x ln 2 minus 2 power x into 2x whole upon x power 4. Let's understand the second example. Y is equal to sin x plus cos x whole upon sin x minus cos x. So dy by dx is equal to, first square the denominator, sin x minus cos x the whole square, and in numerator keep the denominator constant sin x minus cos x, then differentiate the numerator, that is cos x plus minus sin x, apply a negative sign and then keep the numerator constant sin x plus cos x and differentiate the denominator, that is cos x minus differentiation of cos x minus sin x. On solving this further, we get dy by dx is equal to sin x minus cos x minus sin x minus sin x plus cos x into cos x plus sin x whole upon sin x minus cos x the whole square. And on simplifying this, we can get dy by dx as minus of cos x minus sin x the whole square minus sin x plus cos x the whole square. Basically we just multiplied these both, and since these both are not same, we will take minus sign common from here, and the denominator will be sin x minus cos x the whole square. Now let's begin with our next rule, that is called the chain rule. Here, if we have given a function y is equal to fx, we know how to differentiate. But what if we have given a function in which there is a function like f of g of h of x? Here in one function there is another function, and in that function also there is another function. So how we will differentiate this one? So dy by dx is equal to, first start from outer and go to inner. So f dash of gx hx into g dash of hx and then h dash of x into x dash. So basically we first differentiated f function, outer function, which is f dash, and keeping the inner constant. Then we differentiated the second one. Now as f is already differentiated, we shall not include this. So g dash of hx, then after differentiation of this we move to the next, which is h dash x, and don't forget to differentiate the x. So this function is known as a composite function. Example, y is equal to sin x. We know y is equal to sin x differentiation is cos x. But what if we are given y is equal to sin x square? Now here there is a function, and inside there also is a function. So dy by dx will be, first differentiate the outer part keeping the inner constant. So cos x square into, now differentiate the inner, 2x into, now differentiation of x is 1. So we will get cos x square into 2x into 1. Next is y is equal to sine cos x. So in sine function there is cos x. So dy by dx will be, first differentiate outer cos and keep the cos x constant. So cos x into, now differentiate the inner, which is sin x, actually minus sin x, into, and differentiation of x is 1. Let's move on to the next example. Y is equal to under root x. Dy by dx, x power half. So root x is written as x power half. So differentiation of this will be half x, half in minus 1. So we applied the formula x power n. We know n x power n minus 1. So that is it. We can simplify it further and we get 1 upon 2 root x. Actually this is a result, so you can directly remember it, that if y is equal to root x, the differentiation will be 1 upon 2 root x. Let's try this. Y is equal to root sin x. Try this yourself and give the answer in comment. What if we are given y is equal to under root cos x plus under root sin x? Treat this whole as x or something, then under root x is what? 1 upon 2 root x. So it will be 1 upon 2 root cos x plus under root sin x. Now differentiate the inner. So cos x differentiation will be minus sin x, plus under root sin x differentiation will be 1 upon 2 root sin x. Then sin x differentiation will be cos x, and don't forget the x differentiation, which is 1. Next is y is equal to ln x. Start from outer, dy by dx, ln, treat this whole as an constant or x. So ln x, first differentiating this we get 1 upon x and keep the same ln x. Then differentiate the second, 1 upon x, keep this as same ln x. Then differentiate the third one, which is 1 upon x, and the differentiation of x is 1. Next sum, y is equal to under root ln sec x plus tan x. Do this as your homework and also give this as an answer in comment box. Let's try a sum which looks a little bit bigger. That is y is equal to 2 power sine square x plus sine cos square x whole divided by ln x square sine x plus 5. This is a problem which includes almost all the rules. We have quotient rule, we have chain rules and addition rules. So let's try it. So dy by dx, first we can see we apply the quotient rule. So square the denominator, then keep the denominator constant, differentiate the numerator. 2 power sine square x is 2 power sine square x ln 2. Here treat this as a x function, so it will become a power x. So 2 power sine square x to ln 2. Now we have differentiated, but we have to differentiate sine square x also according to chain rule. So differentiation of this will be 2 sine x. This is sine x the whole square. Treat it as x power n. So 2 sine x, and then differentiate sine x, which is cos x, and then differentiation of x is 1. But we are not done. Plus sine n into cos square x. Differentiate this, we will get cos x, cos square x. Then we shall differentiate the inner, which is 2 cos x into differentiate cos x, which is minus sin x, and the differentiation of x is 1. Now we have done with the first part. Now apply negative sign and then keep the numerator constant and differentiate the denominator. So it is ln, and treat this as x, so it will become 1 upon the function which we have treated as x, that is x square sin x plus 5. Now differentiate the inner function, so which is x square sin x. Here it is a question of product rule. So first keep this constant, differentiate this, which will be 2x sin x, plus then keep this constant, differentiate this, which will be x square cos x, plus now phi is a constant, so it will become 0, and into differentiating x we get 1. So these whole will become our full answer. You can solve it further, and if you want such more sum, then I can give you one for your homework. Don't be afraid, try it and practice it. So this is the sum you have to do for your homework. Try it. Actually the answer is really big, so you don't need to type it in the comment box, but do try it. Hope you liked today's session. Thank you for listening. Hit that subscribe button, and also don't forget to like the video. Share this video with your friends. Thank you.